Problem number 5 from the 4th exam of spring 2012. We're given information about some forces, and we want to determine the total torque about point A. So point A is over here on the left. We're given this force of 46 at an angle and 32 going up at an angle. So remember, torque is force times perpendicular distance. So by far the easiest way, I think, for working these is to break them in the forces into components. So we'll break this force into a component vertically. Okay. You can look at that several ways. I would probably look at it as 46 cosine of 20. It would also be 46 times the sine of 70. Okay, and it would also have a component in this direction that would be, where to write it here, 46 times the cosine of 70. Okay, let's do this one in a different color. This one's going to be a component horizontal, a component vertical. This vertical component is going to be 32 cosine 35, and this one's going to be 32 cosine 65 or sine of 35, either one. When you're doing torques, it's important to locate the tail of the components at the point of application of the force, because that's going to help you determine the perpendicular distance to use. Alright, so the torque caused by this component about point A is actually going to be 0. This line of action of this horizontal force component goes right through A. Likewise with this horizontal component, the line of action goes right through A. So the only thing that's going to have an effect is this vertical component and this vertical component. So we're going to write this as the torque's about A, and we're going to use counterclockwise as positive. Okay, so it's going to be our forces times our perpendicular distance. So we'll use the 46 cosine of 20 times this perpendicular distance of 2.3 feet. Oops. 2.3. Okay, this is going to be pounds, this is going to be feet. And then that's going to be a clockwise. This is going to cause a clockwise rotation. So that's going to be a negative sign here. So I'm going to write that as a separate object. Okay. Then we're going to add to that this component, 32 cosine 35, is the magnitude of the force component. The distance is going to be 2.3 plus 0.8. Okay, and it's going to cause a counterclockwise rotation about 0.8. It's pointing up. Okay, right hand rule would give us a positive value. So that's it. That will be the torque about point A. So we'll bring in our calculator, figure that out. 46 cosine 20 times 2.3. Oops, I forgot my parenthesis there. Okay, and that's going to be a negative, so I'm going to multiply by -1 because I forgot that. And then plus 32 cosine 35 times 2.3 plus 0.8, and it's going to be positive. So the answer comes out to be 18.1, or rounded off 18.2, and it's negative, so minus 18.2. Again, this was unit of pounds, this is unit of feet, so it's foot pounds. Okay, since this is referencing this one, so we could either write it as that or write it as a positive 18.2 foot-pounds clockwise. So that's how I'll write my answer. Foot-pounds. You do need to indicate direction, either plus or minus if you've given some reference, or clockwise or counterclockwise for two-dimensional torques.